It starts with silence, a world just like ours. Oceans shimmer under morning light. Cities hum with life. Forests sway in the wind. And then, without warning, the sky darkens. But this isn't a single asteroid hurtling toward Earth. It's all of them. Every asteroid in the solar system. At once. All incoming. From the tiniest rocky pebbles to monstrous giants like Ceres, hundreds of kilometers wide. They're on a collision course with one planet, ours. This is no extinction-level event. This is planetary erasure. And while it sounds like the ultimate science fiction nightmare, exploring this extreme scenario reveals astonishing truths about Earth's vulnerability, the power of celestial bodies, and how finely balanced life on this planet truly is. This is the question. What if every asteroid hit Earth at once? And what would be left behind? To imagine this, we first have to understand the scale. Our solar system's main asteroid belt, located between Mars and Jupiter, contains millions of objects. From fragments just a few meters wide to large protoplanets like Vesta and Ceres. Add in near-Earth objects, Trojan asteroids, Kuiper Belt objects, and stray bodies across the solar system, and the total estimated mass becomes clearer. In total, the combined mass of all known asteroids is about 3 times 10 superscript 2 superscript 1 kilograms. For perspective, that's roughly 4% the mass of the Moon. Still think it's not that much? That's over 30 quintillion tons of rock and metal, all falling to Earth simultaneously at tens of thousands of kilometers per hour. We're not just talking craters. We're talking global shock waves, continent-sized firestorms, oceans boiled away, tectonic disruption, and potentially the complete disintegration of Earth's crust. But let's not get ahead of ourselves. Let's break it down. The first few minutes would be unrecognizable. The sky, once blue, would become a canvas of incoming streaks. The atmosphere would ignite from the friction of countless asteroids tearing through it, each one a miniature meteor trailing fire. Most smaller asteroids, say a few meters wide, would vaporize in the upper atmosphere, creating blinding airbursts like the Chelyabinsk event in 2013, but on a global scale. Hundreds of thousands of these fireballs would detonate simultaneously across every country, every ocean, every wilderness. Shockwaves from the blasts would flatten buildings, forests, and terrain. Eardrums would rupture. Windows would explode. The global soundscape would be a deafening, continuous roar. But those would be the small ones. The larger rocks, tens or hundreds of meters across, would reach the surface intact. Each one would strike with the power of hundreds of Hiroshima bombs. Cities would vanish. Mountain ranges would crumble. Tsunamis would form on every coastline. And then come the giants. The real terror arrives in the form of the largest asteroids. Bennu, 500 meters wide. Pallas, 512 kilometers wide. Vesta, 525 kilometers wide. Ceres, 940 kilometers wide, a dwarf planet. Each of these contains more mass and energy than all Earth's nuclear weapons combined, many times over. If a single object the size of Ceres hit Earth, the energy release would be equivalent to 10 billion megatons of TNT. To hit Earth all at once, these asteroids would have to be accelerated, perhaps by some absurd cosmic event, toward Earth from all directions. Imagine that moment. Ceres slams into Eurasia. Vesta impacts South America. Pallas crashes into the Pacific Ocean. The crust doesn't crack. It shatters. Earth's mantle, usually buried beneath kilometers of rock, is exposed. Molten rock fountains into the atmosphere. Entire continents are ejected into space. The atmosphere itself ignites. Shockwaves travel through the planet's core. Seismic activity registers beyond anything we've ever measured. At this point, Earth isn't just damaged. It is undergoing planetary restructuring. Let's put numbers to it. Each kilometer-wide asteroid impacts with about 1 million megatons of energy. Ceres alone, at nearly 1,000 kilometers wide, would release energy equivalent to all the sun's output in a few seconds, focused entirely on Earth. If all the asteroid mass, roughly 3 times 10 superscript 2 superscript 1 kg, impacted Earth at once, moving at an average of 20 kilometers per second, the energy released would be 6 times 10 superscript 2 joules. That's about 100 million times the energy of the dinosaur-killing Chicxulub impact. Enough to vaporize oceans, melt the crust, possibly even eject parts of Earth's mantle into orbit. This is an extinction. It's planetary reset. Hours after the impacts, Earth would be a smoldering sphere of molten rock. The atmosphere would be stripped or drastically altered, flooded with carbon dioxide, sulfur, and vaporized elements. Global temperatures would spike past 1,000 degrees Celsius. Anything that once lived is gone. The oceans, boiled. The biosphere, erased. Satellites, disintegrated. The moon, possibly scarred or knocked into a new orbit. The collision debris may form a new ring system or coalesce into new moons, as in Earth's early history. Essentially, we'd return to a Hadean Earth, the chaotic, molten phase from 4.5 billion years ago. And just like before, it could take hundreds of millions of years for the planet to cool enough to form solid crust again. If it ever does. Short answer, no. There is no known mechanism that could redirect every asteroid toward Earth simultaneously. Gravity doesn't work like that. The asteroid belt is gravitationally stable, held in check by the Sun and Jupiter. And even if we detonated a sci-fi level device near Jupiter, it still wouldn't funnel all asteroids to Earth. But this thought experiment isn't about realism. It's about scale. Understanding the power of asteroid impacts helps us appreciate why we monitor near-Earth objects so closely. Because even one impactor, the size of a football field, could cause a regional disaster. And a 10-kilometer wide rock. That's mass extinction. We don't need every asteroid to hit Earth for it to be a problem. There is one more layer to this. The solar system is a dangerous place. Earth has been hit before, by countless impacts over billions of years. The moon is our fossil record, covered in craters we no longer remember. And Earth's own surface, constantly eroded and reshaped, hides its scars. But they're there. The oceans, the continents, even life itself, all have been shaped by impacts. The Chicxulub impact ended the reign of the dinosaurs. But it also cleared the way for mammals, for us. And so, while this hypothetical scenario of all asteroids striking at once is impossibly absurd, the reality is that even one could change the future of life on Earth. That's why we watch the skies. That's why we build telescopes. That's why planetary defense isn't science fiction, it's science strategy. Because space doesn't care if we're ready. But we must be. Sometimes, the most extreme hypotheticals reveal the most grounded truths. What if every asteroid hit Earth at once? The answer is, nothing recognizable would survive. But in imagining it, we see the balance we live in. A world forged by collisions, shaped by impacts, but spared, for now, from destruction. Every meteor that burns across the night sky is a reminder that the universe is still out there, that the danger is real, but so is the wonder. And somewhere, floating between Mars and Jupiter, the next asteroid waits. Not for orders, not for purpose, just for gravity.